Hello, here in this session we are going to discuss about how to find the perimeter of a circle using integration. So we are going to find the perimeter of the circle. Perimeter of the circle. For that, consider a sector. I'm naming it as A, B and C. Let ABC be a sector. Let this be an arc of length L. Let theta be in radians and R be the radius of this circle. If this section is very small, consider that sector as very small. See, this is your sector, which is very small. So this forms your d theta. Since the angle is very small, I call it as d theta. This one is d theta and this one will be dl. Since the radius remains constant, this length will be r. Suppose I draw a section like this. Let name this as A prime. So let this section A dash, this will be d theta. So this one is d theta. Clear? So this is your C. Now this A dash C, this portion is I took this piece from here and I pasted it here. So this is your section. Now you have the relation, the angle of an arc is equal to length of the arc, that is arc length divided by radius. This is our formula for finding the angle. Remember, this angle should be in radians. If it is in degrees, this formula is not possible. So the angle must be in radians. On substituting here, you will get angle d theta is equal to, what is the length of the arc, which is A prime, that is dl divided by radius. Since the radius is constant, I can write here as r. So your dl is equal to r d theta. Put this as equation number 1. So see, you got a variable d theta here and you need to find dl. Suppose in order to get the total length, which means the circumference of this circle, you need to integrate this, integrating 1. So integral dl is equal to integral r d theta. Integral dl will be this total length, which means the total perimeter of the circle, which means perimeter. On integrating dl, you will get the perimeter, which is equal to, since r is a constant, I can take r outside, and d theta. Here you have to put the limits. See, d theta is the angle swept by this radius vector, and its minimum angle is, see, this minimum angle will be 0, and the maximum angle is one rotation, one complete rotation. For one complete rotation, it will make an angle of 2 pi radians. So here you have to put 2 pi. Now you have to integrate this term. That is equal to perimeter p. I take perimeter as p. It's the representation for perimeter p. P is equal to r times integral of d theta, which will be theta. You have to put the lower limit here and the upper limit here. Now you have to substitute first the upper limit, which will give you, instead of theta you have to write 2 pi. 2 pi minus, now for the lower limit you have to put 0, which is equal to r times 2 pi. Therefore perimeter of any circle of radius r equal to 2 pi r.